Hello, everybody. I am Takahiko Nagata from NTT Software. Today, I'm very pleased to have a chance to present in AstriCon. Today, I will introduce case study with Asterisk in Japan. I am very pleased if my presentation gives some hint to your business. Also, feedback from you is highly thanks for us. So, this is today's agenda. Today, I will introduce 2 points. First, I will introduce about architecture of our product. This product deploys Asterisk in cloud and publish Asterisk PBX functions as Web API. So, Asterisk can work together with other web services. Second, I will introduce about consideration point for our product to business in cloud. I will go through company introduction. The name of my company is NTT Software. NTT is one of the biggest telecom operator in Japan. My company is one of NTT Group. So naturally, our main market is telecom related, providing solution service based on emerging technology from NTT research and developing laboratories. Next, relationship between Asterisk and our company. We started Asterisk business back from around 2006. Our main product is NGN gateway based on Asterisk. NGN is operated by NTT. It's called Hikaru Denwa in Japan. Its user network interface differs from typical SIP protocol. Our NGN gateway enables typical SIP phones to connect to NGN without any modifications. We have another Asterisk-based product for different purposes. Next slide, decide one example as case study. Recently, we focused this solution. One of our products enables users to using extension phone from outside the company. In this figure, you can find the company in a box. Generally, company has IPPBX, which is connected to the telecom network. PBX has several fixed phones within a company location, and phones are used in company. It is quite normal use case in almost PBX, we cannot use these phones from outside of company. Our product purpose is enable using extension phones from outside of company through smartphone. You can also find a smartphone in the figure. It exists outside of company. And finally, you can find the red color box in the figure. This is our product. By using this product, smartphone can register to PBX via mobile network. Therefore, PBX can treat smartphone as if it is an extension inside the company. In next slide, I will explain gateway functions of our product. As I explained in the previous slide, smartphone reach PBX over mobile network. For use mobile network, we need to consider 2 points. First is security. Second is poor bandwidth. For first reason, security, our product use chip TLS for C-plane traffic and use SRTP for U-plane traffic. And our product convert between chip TLS and chip UDP and between SRTP and RTP. For second reason, poor bandwidth, our product uses Silk codec for U-plane traffic. By Silk, media data is compressed. As you know, media network has limited bandwidth, especially when 3G is used. So compression for media is needed. If no compression, we only hear bot voice. So this chapter, I will introduce our new product. As of today, our business mainly depends on on-premise. In other words, sell as many software which is bundled with hardware. As you know, recently, SaaS-based on cloud is noted in place of on-premise. So for the near future, we will start a new business, which is Asterisk on cloud. In the next slide, explain concept of our business. This is our strategy. First, possible to create service by combining existing product, then scratch development. This reason is based on cost and schedule mainly. Provide platform API gateway, which enable users to create new service easily and quickly. To realize this, provide PBX functions of Asterisk via Web API. For example, contact center, PBX function is Asterisk, and CRM function is any OSS CRM product, such as Sugar CRM, and so on. Each product has Web API. It is HTTP REST API. API gateway aggregate this Web API and provide as a single big service. Here is our overview of this concept. You can see the cloud in the bottom of the figure. On the top of that, you can find several products which provides some functions. We call this function as enabler. From left side, there is Asterisk-based enabler which provides Web API. We created this Web API, which is called from API gateway. And other enabler exist in right sides, such as CRM and so on. You can find API gateway on top of this. We use API gateway by commercial products like us, Layer 7, and RPG. This API gateway has many functions, such as API authentication, API aggregation, API traffic control, and API transform. By using these functions, web developer can easily and quickly build application by combining enabler. For example, in contact center, we use in combination Asterisk, CRM product, and so on. Also, other developer and service provider can use in combination, for example, CRM product and other enabler. We added Web API to Asterisk, so we can develop new Asterisk solutions easily and quickly. So, exist of such usage, we examined WebRTC contact center, and we picked up requirement for WebRTC Web API from function of this contact center. First requirement is authentication and login. After operator of contact center do login from web page, our system will register with SIP over WebSocket automatically. Also, after customer of contact center clicked call button, our system will start call automatically. Second requirement is WebRTC, support for telecommuting. By WebRTC, we can work anywhere, such as on home and other locations, not only on office. And without using any specific device, just use browser. Third requirement is call function for business, used by operator of contact center. This function needs to use also WebRTC. Last, fourth requirement is mechanism for cooperation with other enablers. Example 1, user call with customer ID and operator get this ID, and look up call history from CRM by this ID. Example 2, Asterisk can switch call handling based on GPS location information. From these 4 requirements, we develop Web API, which is difficult to realize using only SIP. This slide describes use case. Figures show contact center use case. In the left side, customer exists. In the right side, operator exists. Between these, our system exists. In this example, first, customer log into the system. Then they select the purpose of call and click call button. After clicked call button, our system initialize and start call to contact center via browser. It is WebRTC call. At the same time, calling by WebRTC, our system notifies some additional information to Asterisk, such as login, customer ID, selected purpose of call, and area name identified from GPS locations. We will use this additional information for 2 purposes. First is used in dial plan. Second is query web application. In first purpose, used in dial plan, for example, we can select linking operator group in dial plan by area name identified from GPS locations. In second purpose, we use in query web application. For example, query web application will get customer ID from Asterisk, and web application get any information such as customer detail, calling history, and so on, which is related with customer ID from CRM. Those information is not put through SIP protocol. It's put through Web API. Our system can run in cooperation with other enablers by these mechanisms. This slide is describe detailed sequence when customer log into the system and call. Let us assume that contact center operator is already logged in. Omitted in this figure, when operator do log in, Web API returns SIP register information such as IP, port, extension number, and secret. And our web client application operator will automatically register by these SIP information. So operator web client run as extension phone. Next, when guest user click call button, our system run 2 processes via Web API. First function of this API, guest user run as extension phone, same as operator. Our system pulls some extension numbers and assign 1 temporary extension number when click the call button. And for security requirement, we refresh secret of SIP by Asterisk real-time architecture. Second function of this Web API, for cooperation with other enabler, store additional information in Asterisk. This additional information is stored in association with extension number, which is assigned temporarily. After this, from dial plan or web client application, operator can refer additional information by extension number of caller. When Web API is returned, these are all SIP register information, such as IP, port, temporary extension number, and secret, so that it can start WebRTC call using SIP over WebSocket. When operator incoming, web client application operator can refer additional information by extension number of caller. Again, system remember additional information related to this call. Operator can pick up the information via Web API called to the system. In end of this chapter, show one issue specific to WebRTC call. This issue is that when started call with audio and video, WebRTC, if we use IVR, such as playback application, we cannot listen to audio, which is played by playback application at WebRTC client. First, WebRTC client start call with audio and video media. For this, Asterisk reply with answer application in the reply includes both audio and video media. Then play audio by playback applications. So Asterisk only send audio RTP and no video RTP to WebRTC client. At this time, WebRTC client receive audio RTP, but never play audio at WebRTC client. Because in WebRTC client never play audio until receive both audio and video RTP. We have two solutions for this issue. First solution is sending a video RTP in IVR. Second solution is invalidate video in answer and validate after incoming to operator. We selected solution A1 because of easy to solve. But this way is temporary solution. This solution is that before status playback, do echo back video RTP sent by WebRTC client. Now, implementation of browser, after receive a few video RTP packets, even if video RTP is stopped, browser continue to play audio. So using echo, we avoid this issue. But this way it depends on implementation of browser. So it is a temporary solution. And some issues exist in other functions. For example, back and call pickup. In this chapter, I will introduce what we considering for business. As described in the previous chapter, we achieved the initial goal. But there are several technical issues for starting service in the real world. So we have started investigation for this issue. Especially, we need consideration for cloud. This table is list which we consider. Mainly, three issues exist. First is multi-tenancy. We need consideration providing service for company which has a few members such as number under 20. In this case, the small company occupy one virtual machine, but this is not a good resource and cost effective. Second is scale out. It is opposite case with issue A. Basically, there exists some limitation on virtual machine template in many clouds. It is a problem when providing service to a company which has a large number of users, such as upper 1,000. In this case, we need scale out for over limitation of virtual machine template. Third is reliability. And the user expects high availability on telephony service. Now, in our architecture, we assigned one virtual machine for each one company called tenant. But this way, it is not a good resource and cost effective. In the future, we want to change architecture such as Plan A or Plan B. Plan A is sharing OS instance and separate Asterisk instance. Plan B is sharing both OS instance and Asterisk instance. If possible, we want to choose Plan B. But for Plan B, we need consideration something, mainly separate data and configuration for each tenant, such as dial plan, user configuration, CDR, and max concurrent call limit. Next issue is scale out because of limitation of one virtual machine template. For this issue, we will use load balancer using ship proxy, and we need to consider something. First, when calling across Asterisk, we need two-time channel resource, such as pack and conference, and so on. Second, aggregation output data of Asterisk, such as CDR, and aggregate CDR ACD groups. Third issue is based on WebRTC. In the case of Asterisk, in the case of WebRTC, ship is over WebSocket.TCP. So difficult to use technique of ship UDP load balancer. And WebRTC requirement media encryption, so need much CPU resources. Last issue is availability, reliability. Sometimes carrier-grade option is required for commercial use. For example, call recovery. Even if virtual machine which is running, established call is down, other virtual machine recovery these calls and continue talking. And the user does not notice switched virtual machine. Last, summary of this session. We started new business, Asterisk on Cloud, WebRTC, Web API. We enhanced Asterisk in the following point, provide Web API, and so on. We expect Asterisk community to enhance with following aspects, multi-tenancy, and so on. We are looking for a partner that can work together. Thank you for your attention. Any questions?
When are you planning on going on production?
When? I will provide this production.
Yeah, this is for what you've done is for testing right now, isn't it? Is this in production?
Yes, this is production. Now we develop this product and 今年かな。This year we will release this product.
Okay. How many users do you have on it? How many companies? What's the scale of it?
Pardon? How many?
I mean, how many, basically, how many customers do you have?
Sorry, not yet decided.
You haven't started, okay.
Maybe depend on specification of cloud resource.
Okay.
But we are not yet decided.
Okay. Thank you.
Thank you.
Any other questions? Okay, thank you very much.
Thank you very much.
And as a reminder, there are evaluation forms. Please fill out and put in the bin next to the projector.